Okay, what we did with vectors, a lot of it is going to kind of feel kind of familiar with polar graphs. So, so I think today, actually, the rest of this week, everything we've done with the vectors units is going to, yeah, it won't feel too different in some cases. You guys can turn to page 33, the very second last page. I have the calendar there. You can decide to tear it off and have it as a separate page, or if you want to have it all under one packet, I stapled it. And the back page is a summary sheet, and we'll refer to those formulas as we reach them. I really think that today and tomorrow's topic is not a whole lot, but that's why we're going to have a short quiz or a quiz just over the material that we're going to cover today and tomorrow. We'll have Thursday to review, and then and Friday quiz. Okay. Next week we'll have a check-in quiz Wednesday, and then the following week we'll have a test on this unit. Okay. All right, so let's go to page 2. Okay, I'm going to skip the Desmos activity, and we're just going to go directly to the notes here. So this is, so page 2. Okay, we'll start here. There's more than one way to plot a point. Okay, so let's say we had a rectangular, well, we had a coordinate plane. Okay, so let's say we have a coordinate plane here. If I wanted to plot a point on a rectangular graph, we can just go left. Let's say the point was in the first quadrant, and let's say it was 3, 4. Then we will go left 3 units and up 4 units, right? Let's say I call that point A. So if I want to find that point, I can just go up to the left 3 and up 4, and we can treat those as X and Y values, right? So what I want to show you is that we can also arrive at the same point, this point A, by relying on the angle and the hypotenuse. So if I know what the angle measure is, and if I know what the length of that hypotenuse is, I can also reach that same point, right? So let's say theta is some, let's say, 35 degrees, and then I'm just going to walk out R units, and that will take me to the same point. So that's what we're going to be focusing on today, that we can arrive at the same information as a rectangular graph, but using a different piece of information to get there. So the ordered pair for a polar graph is r comma theta. R being the radius, and theta being the angle. So if we know the angle, if we know the radius, we can reach the same destination as if we just had the X and Y values. All right, so a couple of notes I want to add, include in here. If I have a positive theta, is counterclockwise. So sometimes I like to abbreviate CCW. So counterclockwise is where we go left. So imagine the steering wheel, you're just turning that steering wheel left. So you're going, that's counterclockwise. If I have negative theta, then I'm going to be counting, or I'm going to be moving clockwise. That is going this way here. Okay, if I have a positive R, then that means my value is going to be on that theta value, or on that theta. But if I have negative R, then negative R is the opposite direction along that theta line. I'll talk about what that means, but right now you can just copy that down. Okay, example 1, or bottom of the page here. Plot the points given R and theta. So what's going to feel a little bit strange here is that typically we read the first number and then we follow with the second number. But with polar, maybe it's a lot of times it's more helpful to identify the angle first before you realize, before you figure out how far you want to move away from the origin. So what we're going to do is we're going to find that 135 degree line. So if you think about unit circle values, 135 degrees is going to be in the second quadrant, and it's going to be a variation. Its reference angle is going to be 45 degrees, right? It's going to be 45 degrees away from that 180 degree line. So we know 135 degrees is going to be that middle line here. Okay, it's going to be the 45 degree variation in the second quadrant. So we know where our angle is. Okay, this is going to be 135 degree line, and now that 2 tells us how far out we're going to walk out. How far we're going to walk out. We're going to walk 2 units out from the origin. So 1 unit, 2 units. So there we have point A here. Okay, any questions? So we're plotting a point, not using the X and Y value, but rather using polar points or polar information. Okay, let's see if we can plot point B. Start with the second number first, 7 pi over 6. Which quadrant is that in? Third quadrant. And it's going to be the angle measure closest to the 180, right? So here's my 7 pi over 6. If I want to walk towards 7 pi over 6, 1 unit out, there it is, point B. Okay, any questions so far? All right, so what we're going to discover with polar points is that we're going to have multiple ways of arriving at the same point. Okay, we're going to talk about, it's not quite the case with rectangular graphs, right? Rectangular graphs, there's only one way of getting to a specific point, the X and Y value. But with polar, we're going to have multiple ways to arrive at the same point. Okay, let's talk about that. So page 3. So we have point E showing on top of page 3. Name the location of E in 4 different ways. Okay, between negative 2 pi and 2 pi. So let's start with the most obvious one, the easiest one to identify. And that is, we know that this is 7 pi over 6. How many units out are we walking? 3, right? So point E, 3, 7 pi over 6. Oh, appreciate it. Thank you. So what we could do is we could have a different way of representing 7 pi over 6, right? What if we started at 0 and we did a negative degree measure or a negative radian measure? So if I went in the negative measure here, what is 7 pi over 6 from a negative perspective? Yeah, negative 5 pi over 6. And basically, we're going to the negatives, right? So we can either kind of work from it backwards, or you can always add or subtract 2 pi to get to where you want to go, right? If you want to just do coterminal angles, you can either add or subtract 2 pi. So we can either think of it as, okay, I'm going negative 5 pi over 6, or you can think of this as, okay, 7 pi over 6 minus 2 pi, right? If you want to just do it, this feels more straightforward, that you just adding or subtracting 2 pi to get another rotation in a separate direction, but getting to the same point. 7 pi over 6 minus 2 pi would be the same thing as negative 5 pi over 6. Okay. So we can also think of it as, well, negative 5 pi over 6, 3 units out is still the same location, right? Now, if we added 2 pi to 7 pi over 6, then we're going to be outside of this range here. We're only looking at what's between negative 2 pi and 2 pi. So here's another way for us to represent that same point. Okay, but we're going to use a different quadrant here. Do you see how this line, if we were to follow this line here, it would go into the first quadrant? And if we went to the first quadrant, on the other side, what does it come out as? Pi over 6. Okay. So here's pi over 6. You see how pi over 6 is kind of related to 7 pi over 6 because it's along the same line, it's just different quadrant. So another way that we can represent the same point is we can say, well, what if we start at pi over 6? Okay. But instead of walking towards pi over 6, we're going to walk away from pi over 6. And that's where a negative radius means. A negative radius means that you're walking 3 units away in the other direction of that angle. So 1, 2, 3, it would arrive at the same location as point E that we had from before. Okay, does that make sense? Okay. So what if we created another order pair where we're walking away from pi over 6, but then let's call pi over 6 a different name. What's the coterminal angle of pi over 6 that's maybe in the negative region? Yeah, we can always subtract 2 pi to get to a coterminal angle as long as it falls in that category. So if I subtract the 2 pi, the same thing as pi over 6 minus 12 pi over 6, which is negative 11 pi over 6. We know that negative 11 pi over 6 is the same as pi over 6. So negative 11 pi over 6 will walk 3 units away in the other direction. These are all going to take us to the same location, point E. Okay. Any questions there? Okay, does anybody still need this top page here? So for example 3, I want to see if you guys can try this one. Now this one is going to be, I did not put enough directions here, so I'm going to put that now. Let's say you want to plot point A. And you want to provide 3 more points that achieves the same as point A. And your theta is going to be between negative 360 and 360. So let's do, let's plot point A first, and then see if we can create 3 more different pairs of coordinates that also locate the same point. Okay, so 135. Let me highlight that line so you can kind of visualize how we're going to use the other quadrant to help us get to the same point. You can always add or subtract 360 to get coterminal angles. You can always add or subtract 180 to reach the diagonal quadrant, right? Does everyone have an order pair that also takes us to the same point? Okay, what's another degree measure that will take us to 135 degrees? Yeah, if I subtract 360, I can kind of go backwards, right? So we know that 135 minus 360 so negative 225 degrees is the same as 135 degrees. So we can also say 4 comma negative 225 degrees. And we're falling within the range of degree measured, right? Within 2 rotations either way of 0. All right, what about starting from this 4th quadrant here? What's an order pair that we can also take us to point A? Yep, 315. It's in that 4th quadrant. It's the 45-degree variation in the 4th quadrant, and we're going to walk backwards away from 315, negative 4 units, and that will take us to the same place. Good. Let's do one more. What's another name that we can call this 315? Yeah, we can always subtract 360. The same location as 315, so we can also walk away 4 units. Okay, any questions there? Okay, so that's really all there is for today's lesson. We're just going to do page 4. We're going to have you guys work on this page, and I will work on it at the same time that you guys do, and you can check your answers as I work through them. And then when you guys finish, I'll come around and check you guys off. Okay, so that's all we're doing for today.
Number 5 and 7, is that a negative?
Yeah, this is negative 5 pi over 6, and this is negative 5 pi over 3. That's a little bit grainy, so thanks for asking. Remember, if you don't recognize a negative angle measure, you can always add 2 pi to it to get to a coterminal angle that feels more recognizable. Oops. See something here. All right, double check my work. Is that what you guys got as well? Yeah.
Can you explain how you plotted,
Yeah, so -4 pi over 3, we know that is basically working backwards. We know -4 pi over 3 plus 6 pi over 3 is 2 pi over 3, so it's going to be along the same line here. So we know that -4 pi over 3 is going to be walking out towards second quadrant, but I want to move 5 units away from second quadrant. So I got to go 1, 2, 3, 4, 5. Yeah. And then that's just creating 3 different variations in terms of radians.
Aren't you using the -pi over 3 or the?
Oh, this one here?
Yeah.
Yes, thank you. This should be -5 over 3. Yeah. Okay, any questions here? So I want to make sure that we're comfortable creating all these different variations of the same points, either subtracting or adding 2 pi or -2 pi, and then either walking towards or away from that quadrant. If you want to walk away, then you got to do negative radius. If you want to walk towards that quadrant, you got to do a positive radius. Okay. All right, I'm gonna come around and check your pages 3 and 4, and let me know if you have any questions as I circle the room.